Hi guys, and welcome to the latest topic in Year 10 Science, Evolution and Earth History. And I know we started this topic last term, but I'm going to give you just a couple of little catch-up slides and videos just to make sure we're all together and keeping together as we move forward this term. I will give you a bit of a reminder if you've only just watched this that posters are outstanding, the ones that I've got so far, and we should have a nice little geological time wall with some excellent QR codes. But at the moment, let's have a quick look at fossils. As far as you are concerned, all you need to really know about fossils is a lot of stuff that's probably mostly revision for you. So fossils that are remains of once living organisms, and they can occur in a lot of different types of forms. So we can have whole organisms where the entire organism is preserved. So we've looked at amber as one example. So insects that are trapped in the sap of a tree can then, if that tree dies and is buried, can remain in the amber and then become fossilized. Other processes like mummification, freezing, are designed to preserve the entire organism, at least in some form or another. You make casts and molds with plaster of Paris just to try and duplicate the process that occurs in, or at least one of the types of processes that can occur in fossilization. So the mold is the shape and the cast is the infill. So usually that's a petrified version, like a mineralized one with different minerals that have filled that cast in. And that brings us to the next type, which is things like petrified wood, which is wherever the soft living tissue has been replaced by hard minerals. This can also occur for some of the hard parts like bone or shell, but it can also occur for the softer tissues as well. And so we see petrified wood, for example, as an example of where minerals have actually replaced the living components. And then we also find trace fossils, so not fossils of organisms themselves or the parts of them, but some evidence or some trace that they were there previously. So footprints is a good example of that, and coprolites, which is fossilized animal poo, which tells us something about the diet, which can tell us something about maybe the size of the organism if we're looking at footprints. So that's an indication often of size because of how far apart they are, how big the footprints are. And all of this gives us a bit of information about fossils and the different types of organisms that lived before us. So then if we're going to form fossils, then we need a couple of important conditions that are going to promote good fossilization. The first of these, and probably the most important, is a quick burial. And this is why fossils found in the oceans or seas, rivers or streams, any water bodies really, are more common. Because organisms that die can settle down to the bottom and sediment settles on top of them and they become fairly quickly buried. The problem that we have for most terrestrial organisms, and the reason why we don't have as many fossils of terrestrial organisms, is because they're not protected from biological or environmental disturbance. Winds can redistribute the material. Organisms, scavengers, can come and eat it, crack it, break it up into small pieces, or actually consume it. And this is not a good environment if we want fossils to form. So we want to make sure that our fossils are protected, our potential fossils are protected from any biological or environmental disturbance. The exclusion of oxygen kind of relates back to this one, because what it does is it often reduces the opportunity for microorganisms to break down the material. So we reduce microorganism breakdown by excluding oxygen. We make it as quiet and as undisturbed as possible. Now, fossils take time, so there has to be a reasonable amount of time for all of this to have occurred, and for the fossil, or for the potential fossil, to sit for a large amount of time undisturbed. And we also need to make sure that there's no heat and pressure. So processes that form metamorphic rocks are heat and pressure. And when you have heat and pressure applied to rocks, it can actually melt the minerals and then recrystallize them again, which is nice if you're going to go from something like a limestone into a marble. But the problem is any fossils that were present in the limestone are likely to be destroyed and will not be present in the marble. So these are the sorts of conditions that are important for fossil formation. Make a little list of those, and that'll do us for today. Thanks for watching.